Assalamualaikum warahmatullahi wabarakatuh. And very good morning. I bid to Dr. Ruzaini and Dr. Azrita as my panel. Okay, today I want to present about my FYP2, which is the project entitled Optimization of Step Feedback Controller using Artificial Bee Colony ABC Algorithm for Half-Car Suspension System. Okay, my name is Muhammad Avi Firdaus bin Muhammad Zamri. This is all about myself. You all can contact me through my phone number and email. My supervisor is Mr. Muhammad Fairuz bin Abdullah. For content, uh, I have introduction, research motivation, problem statement, objective, scope of project, literature review, methodology, results, conclusion, and future works. Introduction. Introduction about suspension system. Okay, suspension system. Designing and modeling of car by the factory is different, which is produced to make sure it fulfills the requirements of consumers. Okay, suspension system design are based on road handling, load carrying, and their passengers' comfort due to conflicting demands. Second, it provides a good road holding in order to optimize passengers' comfort and maintaining continuously the tires friction between the road surface. Then it also provides support to the car and equally ensure perfect comfort for the passengers. And the suspension system performance recently has been developed due to increasing of vehicle efficiency and also demands in vehicles. Suspension system is divided into three categories, which is first, passive system, second, semi-active system, and third, active system. We can see that for passive system, it doesn't have actuator, which is the actuator is function is to control the body and the wheel from the bump. Then research motivation. Research motivation. First, primary role of suspension system is to ensure the safety function. Comfort is one of the key criteria in the structure of car suspension system. Okay, for the aim of the car suspension system is designed, first is to reduce the movement of the car body generated by the road surface. Second is to protect the car body, and third to keep the car passengers satisfied and for car handling. One of the important element in the car is shock absorber. In the other name, we can call it as a damper. Damper is the one that contribute both to driving safety and comfort. The production of shock absorber is difficult to estimate with precision as the car's demand increase existing of the shock absorber. So, this kind of term make me feel like to explore about the suspension system. But I'm more focused to the half car suspension system. Okay, problem statement. Problem statement, I have four problem statement. First, passive suspension system cannot provide comfort for a different quality of road surface and driving situation. It means that's because for the passive suspension system, it doesn't have actuator to control the car from the bump. Then, second, transfer a lot of road input or through the car on rough roads during heavily damped or too hard suspension design. Third, reduce the car's balance in turns and shift the lane and sway the car. And the last one is the passive suspension system. It's an open loop system. So there is no feedbacks to fix the error of the system. It's not similar with the active. For the active, we have closed loop system and it can feedback to fix the error. Okay, objective. For my project, I have three objectives. First, to formulate a complete mathematical model in state space form of a half-car suspension system. Second, to control a half-car suspension system using artificial bee colony algorithm based on state feedback controller. And third, to compare the performance of the half-car suspension system between artificial bee colony algorithm with state feedback controller and also conventional state feedback controller. Scope of project. My scope of project is first design of half-car passive and active suspension system using MATLAB Simulink. Then I applied using state feedback controller into the active half-car suspension system. Then I simulate the design using MATLAB software. Then the state feedback parameter is optimized using artificial bee colony algorithm. And the last one is I compare the result between the state feedback controller without artificial bee colony algorithm and state feedback controller with artificial bee colony algorithm. Literature review, half-car suspension system. Okay. When talk about half-car suspension system, it has 4 degrees of freedom, which is include a body of the car, 2 axles and 2 passengers. Bounce and pitch are called of body motion with each axle having its own bounce. The suspension of the car tires and passengers seat is designed in parallel with the dampers of the linear spring. When the front tire or the rear tire or both of front and rear tire hits a certain road profile, that will create an upright force. For example, when it hit a bump, so it will create an upright force to the car. Transmit to the wheel, lead to the vertical acceleration of the wheel. Okay, this is the diagram of half-car suspension system. For state feedback controller, state feedback controller is function to optimize the stability of the system response and to suppress the vibration generated from the road unawareness. So it also improves the transient response, reducing settling time for the system. Okay, this is the example of the state feedback controller, which is it has the plant and there is a feedback from the output to the input. It will loop in this area. Okay, for artificial bee colony, ABC algorithm is an optimization algorithm based on honeybee foraging's intelligent behavior. It is spread over a long distance at the same time it accesses many food sources. It has divided into 3 groups. First, we have employed bees, onlooker bees, and scout bees. All the 3 bees have their own jobs to do. Methodology. For methodology, first I start then literature review, then I design half-car model that divided into 2, which is passive system and active system. Then I apply a step feedback controller for the active and also artificial bee colony algorithm I apply. Then I simulink. But quite different with the passive suspension system, I do not apply with any controller and ABC algorithm. Then I simulink and result and analysis end. For the result, this is my plot diagram for passive car suspension system. And this is my block diagram for active car suspension system. In the middle of the block diagram, I have a sub-block, which is inside the sub-block, I have active car suspension system. We can see that this is 16 gain because I divided into 2, which is front and rear actuator. This is my active car suspension system. Consists of acceleration, velocity, and displacement. Okay, this is the parameter of half-car suspension system that I have been used based on Yahya Maksam journal. This is my road profile. I have applied about 0.1 meter road profile, which is the bump from the road. This also called road disturbance. Okay, this is my result from body displacement we can see that for the conventional state feedback controller without artificial bee colony, I get the result about 0.2 meter for the displacement, but for the when I apply artificial bee colony, it will optimize the result, and the result shows below than 0.12 meter. So it's give a better performance. This also for real body displacement. For conventional state feedback controller, I get 0.15 meter, but when I apply artificial bee colony algorithm, I get the real body displacement below than 1.5 meter. The settling time also become faster when we compare both of them. Then this is from body acceleration. We can see that for conventional state feedback controller is higher than when I apply artificial bee colony algorithm. Then this is real body acceleration. Also give a better result when I apply ABC algorithm. Okay, this is my convergent plot of 50 population and 100 iteration. You can see that it start from 40,760. Then it will achieve a slow convergence towards the optimum value in 80 iteration, which is 1101 value for the objective value. Okay, conclusion. In a conclusion, first, passengers' ride comfort, body motion, and road handling, suspension operation are the reliability characteristics that are of greatest importance when designing the vehicle suspension. Then, I able to simulate the half-car suspension system based on my mathematically model that I have been derived. For future work, first, we can consider using a higher level of controller instead of we using a step feedback controller. For example, we can use a fuzzy logic controller, neural network controller, and the other controllers. Then a complete car system to be controlled can be designed. This will achieve a better control for overall performance. Third, hardware design for suspension system must be created. But I think this is need a very high cost to build the system. So when we apply the hardware design, we can see the real about the suspension system. Then the last one is tuning this system using the other algorithms such as particle swarm optimization (PSO) algorithm, and colony algorithm, and genetic algorithm. From this, we can compare which algorithm can give a better result. Okay, this is my milestone from FYP1 until FYP2. Okay, that's all from me. Thank you.